Welcome back to the Alaska Tech Talks in May. Crazy to think that we are already at the end of May. Time really flies. I think I say that every month, but nonetheless. Hi, everybody. For everyone who doesn't know me, my name is Helena. I am Alaska's community manager, and I'm excited to welcome you to today's Tech Talk number 36. Please note that this session will be recorded and will be uploaded to YouTube later on. Um, as always, agenda-wise, we are going to dive straight into today's Tech Talk. And after that talk, there will be some time for questions and discussions. You can write them in the chat as we go, or you can just wait for after Tassilo will be done with this presentation. And then he'll answer those questions. And then after that, I'll be giving a quick overview on some news and events from the community. And then I'll be announcing the next Tech Talk. So without further ado, please welcome Tassilo Tanneberger to today's Tech Talk. He is the director of the board at DDIX, and he'll be talking about one of our newer projects, IXpect. So I'm going to give the mic over to you and the presenter rights, and then you can go right ahead. Presentation rights, you should be able to share now.
Yeah. You should be able to see my screen.
Yes, we are.
All right, very cool. Yeah, so I'm Tassilo. Thank you, Helena, for the very nice introduction. Yeah, I'm heading DDX, and I'm presenting today IXpect, which we developed at DDX and handed over to Alaska basically a couple of months ago. And this is a bit of a quick roadmap, what we're going to talk about. Quick words about DDX, a bit of the challenges, then design of the tool, deployment, what you can monitor, notifiers, and at the end, like a quick discussion and outlook. So DDX is the Dresden, a small community X. We are recently founded, only a couple months younger than Alaska. And we are operational since 2024. And we are, slowly, progressively growing, adding more and more networks to it. For example, also Cloud and Heat and the Alaska demonstrator, for example, also joined last fall. And so we are basically connecting more and more networks. And we have two POPs, so 2 points of present address that we operate. And we have we added a lot of hardening and switch configuration. But what we were missing were some nice way to enforce IXP LAN hygiene. And let's quickly basically talk a bit. So quick words about what is an IXP to catch everybody. IXPs are basically nothing really more than a big peering LAN where different the routers, different networks connect. We provide a root server, which basically you as the joining network, your root server talks to our root server, exchanges IP address prefixes. So basically you learn via this root server what other peers, what IP address spaces are available at that IX. And then you have this large peering LAN, where you over exchange traffic. So it's the big takeaway for this talk is it reduces latency, it increases the internet's resilience, it gives, for example, also CDNs to lower latency access to, for example, eyeball networks. So eyeball networks, basically networks with a lot of, for example, end customers. And from a technical perspective, what makes it a bit challenging is it's a network, basically it's a place where many networks meet. So you have big exchanges like, I don't know, in Frankfurt, have multiple hundreds connected networks. We are not at this point, but we still want to basically that the problems still exist already on a smaller scale. And what a big peering LAN is at the end is one big broadcast domain. So one big broadcast domain where, for example, ARP packages basically propagate to over all the switches to all the clients. And so this is what network engineers call BUM traffic, so broadcast traffic, unknown unicast, and multicast traffic. So basically traffic that is not directed towards like a single other peer, but is like broadcasted inside the peering LAN. And what makes this now a bit challenging is that this is actually not like the full picture. The full picture of an IXP looks a bit more like this. You have POPs, basically this peering LAN or this broadcast domain spans multiple IXP POPs. So you have, for example, we have 2 POPs and we have what is called a VXLAN EVPN underlay to let it look like it's one big broadcast domain. But then you have peers that connect directly to your peering LAN. You have peers that connect via, for example, their own switch to a peering LAN. But you also have peers that come from a longer distance away, and they buy some layer 2 backhauling, for example, to travel from Berlin to Dresden, right? And if in the most extreme cases you connect multiple of those layer 2 backhauls, you potentially can nest them, and so your broadcast domain becomes larger than you initially or you would expect. And so IXpect basically tries to solve this issue and gives some lets you know, for example, what is actually going on. And so there were a couple of tools in the past that we looked at and we were not particularly happy with them. The primary reason why we were, for example, were not happy with them because most of them were very much dead. And so, for example, ARPWatch is, for example, a tool that is not only used by, for example, IXP operators, but it basically gives you like an information, for example, about what ARP messages are flying around. But that's not the whole story, so we're not really fully happy with this. There's a thing called IXP Watch, which it helps you. It is already pretty close to what we were doing, but it didn't have all the features and was also deprecated. But then there's also some other projects like ARP Sponge and proxy ARP detection. But so this was a bit of inspiration. We combined those tools, and before we started implementing, we set ourselves a couple of principles. And the principles are safety and security come first. So we do not expect any packets to be trustworthy. They're all basically foreign, and we don't no critical. We don't trust them in any way. IXpect fully works passively. So there are, for example, tools that to protect, for example, protect against proxy ARP, for example, tries to, or in order, for example, to detect proxy ARP, tries to inject packets into the peering LAN. And that's something that we really did not want. IXpect fully operates passively. So we only read those BAM traffic, but we do not emit anything to, for example, detect packets. We make very sure that we don't leak any traffic from, for example, our management network into the peering LAN and vice versa. And so there's hard isolation, very important, make security easy and so on. And this is the rough architecture that we have for IXpect. So we have a couple of ways we can ingest traffic. So there's basically 3 main ways. You can either load a PCAP file if you, for example, did with like TCP term a capture of the traffic you want to analyze. You can feed this into IXpect. You can hook directly into your VXLAN underlay, or you can basically sniff network ISO-NetDevs network devices via BPF. And then we have a couple of probes where we analyze and take apart those packets, and then we produce events from them. We aggregate them, batch them, and then we emit notifications to potentially us, the administrators. And the way IXpect is deployed, so the way we, for example, is, so as I already said, it's fully passive. So you have the peering LAN, all the peers are connected, and then there's basically a port where, or could be, for example, a port where IXpect sniffs. That the problem is here, IXpect basically needs to live between 2 worlds. So you have the peering LAN on one side, you have the management network on the other side, and IXpect needs to read the traffic from the peering LAN in order to analyze it. But it needs to emit notifications to our regular management infrastructure. And the standard way, for example, the naive way of doing this is you use IXpect, which is basically a way for you can on Linux, you can use this flag so the Linux kernel basically copies every packet for you that he receives on some network device to you. And then IXpect would get them. But the problem here is, of course, that nothing, like if you do not actively unconfigured on your Linux, for example, ARP messages received on your management network device will leak into your peering LAN. And that would be probably bad, or would be bad, because other peers then learn about, for example, they fill up the ARP tables and peers learn about your management network that shouldn't be there. And so we need some different way. And the way what DDX really uses heavily also for other paths is a feature called network namespaces. Network namespaces, the Linux kernel guarantees you that nothing will leak through the other one. So we still use this AF packet, but we basically split. We have then two namespaces. One is the peering LAN network namespace, and one is the management network namespace. And IXpect lives in the management network namespaces, receives the packets from the peering LAN netdev, and then produces events into the management. And so we don't have the problem of ARP leaks that ARP messages from one network leak into the other. And yes, a couple of the VXLAN, this is supported natively, so we can just really hook into it. And we basically add, so this VXLAN, how it works is that you can configure those IMED routes, and you can basically set an IMED route so that basically it forwards traffic to IXpect. So that's the way how it would work, how you would do the setup bit with VXLAN. And so, okay, we have packets, we get them. What do we do now with them? And so IXpect provides what we call probes, and probes are basically modular pieces inside IXpect that ingest traffic and produce events. And so, for example, we have the ARP Bogon probe, which basically emits events if the source or target IP address in an ARP message is not basically inside this configured list. And for example, for us at DDX, we precisely know which IP addresses are available at our IXP. And so ARP Bogons really should not be there. And so we can get warned if, for example, somebody suddenly starts emitting new IP prefixes. Same, for example, for ARP neighbors. So if somebody, we know precisely, for example, which MAC address each of our peers has, and we know precisely which peering LAN IP address we give it. And so those static mappings are known. And for example, if a peer now, without us knowing, changes its MAC address, we also get notified. But this could also be used for if somebody suddenly connects a new device, or there's basically something really fishy going on, we get messages. And so you get new basically there's a new dynamic thing. And this is also, for example, we also have either of having a static resolution. We also basically IXpect also can be used to have a dynamic resolution. So we have a small Redis as instance, so it learns new mappings. And if an old mapping is invalidated because a new ARP message comes in for that MAC/IP address mapping, you get the message. This is, for example, BUM rates are pretty interesting, for example, for detecting ARP storms. So you get you can set thresholds for broadcast, multicast, and unicast. Basically threshold windows, you can set a window basically on how much time this is aggregated. And if you now get suddenly a lot of ARP messages, you then would basically get a message, okay, my BUM rate broadcast is exceeded. And so you could be warned about different kinds of things. Same with ether type. Ether type is another thing that we monitor for. So inside a peering LAN, you really should only see IPv4, ARP, IPv6, maybe ICMP v6. but that's basically it, right? So all other types of packets also shouldn't be there, so we can be alerted about it. IPv6 bogon is for basically same with like the ARP bogon, so basically unconnected or IPv6 prefixes that really should not be there. So unconnected networks. Neighbor is also, this now monitors ICMP v6, and here it's the same with the v4 version. We basically alert you when a new mapping is found, you know, an unknown mapping is found between like a IPv6 and MAC address. This is I think one of the last things. So in IPv6 there is basically IPv6 router advertisements and router solicitation. You also really do not want this inside your peering LAN, that suddenly, I don't know, two devices on your network suddenly basically figure out, okay, there's this other router. That's something you want to also avoid. And the last thing that IXpect currently supports is for spanning tree protocols. So if somebody suddenly starts speaking spanning tree protocol inside your peering LAN and produces these MPDU frames, so the spanning tree, how it works is that it tries to figure out basically like, okay, where's all my nearest neighbors? And if you see those packets and somebody is trying to speak STP inside your peering LAN, which it really shouldn't do. Because, for example, if other peers then also have misconfigured STP, you know, they would, you know, the eBGP grab would be, they would suddenly start speaking iBGP inside the place where eBGP should be spoken. And so we produce those all kinds of events, and what we do with them is we batch them. So you get, if you get like a lot of messages, you don't want to be overwhelmed. So we basically group them by data and event type. And that's, for example, how one of those emails, for example, would look like. So you get, okay, I saw a IPv6 router advertisement. This is the offending MAC and IPv6 address. I have basically one of those events. So it happens once. And here is basically a sample PCAP for you to analyze the packet further. Right. So this is basically how one of those messages that we get if something is happening. Yes. And so this was already basically what I just showed was, for example, one of those emails that this project emits. And this, so this you can basically configure them, and you can, for example, also select, okay, I want that, for example, different types of messages go to different alerts, right? So you, for example, say, in this, for example, reference config here, you would say my ARP neighbor and my IPv6 neighbor unknown is very critical, and then should go to my alert email address, and everything else should go to my bulk, right? And so there's, for example, events like, okay, if my bum rate is, you know, once too high for one thing, yeah, I don't really care. But like critical things, for example, like those ARP neighbors, they should directly go, I don't know, to my NOC email address and alert my admins. We also have what we call an HTTP notifier. So you can basically set, configure like a webhook that then basically alerts you to something. And this could be, we have basically already a couple of flavors. So we basically use this HTTP probe to implement like a couple of flavors. So for example, we personally at DataX use this matrix integration. So it basically uses this HTTP hook to basically shoot a message against our matrix server, and it says like, okay, here's basically, here are some alerts that you have. But we, for example, also added Slack support. And for example, on our to-do list is also like a Jira integration that you can also have like, basically get like, automatically open like a Jira ticket. Here's something wrong, please take care of it. And so a couple of more points. So IXpect can also be could also be utilized outside of IXPs. one thing, for example, is that those bum rates. So, for example, ARP storms and something is not something that is, limited to an IXP. So you can also have this in your OpenStack deployments. And so you could be, this could be configured to permanently run and alert you about if there's, for example, like an ARP storm or something. And for example, also potential misconfigurations are quite easily detectable. For example, if the ARP neighbor or the IPv6 neighbor probes, where you get alerted, okay, there's fishy packets that shouldn't be there. But the big summary for IXpect is it really helps you keep your network on the lowest level clean. You shouldn't have any packets like. There should not be like packets that like IXpect really helps you to identify potential misconfigurations. So if one client, for example, configures the wrong IP address, IXpect easily can tell you about it. If a client suddenly speaks IBGP into a region where eBGP should be spoken, IXpect helps you find those misconfigurations. So it's a very good tool to, occasionally basically run inside your network to basically just check what is going on at the deepest layer of my network stack. And this is like the big, I think, go around, in the, it's Friday, but maybe like as the last thing you do, check out IXpect, run it like where you actually never looked into what packets are going there, and you will probably find interesting things, interesting packets that, maybe are right, maybe are wrong, but it gives you some certainty that there's no, faulty configuration inside your network. Okay, and we have a couple of things more on the IXpect roadmap. So we are currently working on an L4 basically protocol probe, so that you can basically, for example, check for different layer 4 protocols that you maybe want, that you maybe don't want. There is, for example, there is a thing called EuroX, which is basically the umbrella organization umbrella organization for different IXP operators basically in the EU. And they have a standardized format called IXF member exports. So we want to have automatic basically integration of that. So we can automatically, instead of having to go for some Jinja templating to generate the config, we basically can directly ingest this IXF member format. So that we, for example, automatically know, for example, this is the IP and Ethernet mapping without having to generate the config ourselves. Other big questions are, for example, for us, maybe, do you have additional packet sources that should be added? So right now we have those 3 PCAP, VXLAN underlay, and NetDevs. Maybe there's more that you potentially need, especially also like thinking in like a cloud context. Maybe what's the best way to get them out there. And currently we provide packaging for Alpine Linux. So Alpine Linux, we operate all our root servers with. We have packaging for Debian, and we have a nice NixOS flake, which you can test out and probe it out. All information you find here on the IXpect.net website, and our code is on Kurtberg, IXpect/IXpect. And with that, I think I'm done, and I'm very happy to receive some questions.
Okay, thank you very much, Tassilo. This was great. As he's already said, if you guys have any questions, sometimes it needs a minute for those questions to come in, but
sure.
Shoot.
Do you prompt them, or do I need to read the chat?
You don't need to read the chat. I'll tell you if somebody writes something in the chat.
Okay.
Okay. I'm assuming there are no questions. If you guys do come up with any, then you are, I'm sure, very welcome to ask them later on. You can always reach Tassilo via.
So we have basically a matrix link on our website. So if you're interested in trying it out, there's basically a couple of people inside the chat that actually actively use it. So IXpect is used by a couple of IXPs in Europe, like for example BKix in Berlin, or Franconix in Frankfurt, not in Frankfurt, in Nuremberg. But we also basically right now there's a couple of trial runs, for example, also at London. So if you have basically questions, just reach out inside this metrics chat, or if you actually test it out and try it out, this issue section is open, and please feel free to add like a tip or bug or whatever you find. Yes.
Right. Perfect. Alrighty. Then thank you so much, Tassilo. This was really great. I'm going to sit. Hang on, someone's typing. Oh, Linda just said thanks. I am going to steal your presenter rights.
Yeah.
Alrighty. Can you guys see my screen? Yes, perfect. Okay, moving on to the news and events section of this Tech Talk. Last week, I think a few of us in this room today visited the SCS Summit 2026, and it was a great event. First and foremost, it was really fun. We saw a lot of familiar faces again. And a big shout out to the Open Source Business Alliance and the Sovereign Cloud Stack for organizing such a great event. I think we're all aware that the SCS community and the ALASCA community have quite the big overlap. So it was nice to see a lot of familiar faces, but also some new faces. And we had some great discussions and talks, and just an overall great time. And ALASCA was involved in the program via this panel moderated by Daniel. He currently works at Alaska via the Alaska Focus Funding Project. And yeah, as I said, he moderated the panel on open source standards in practice. And the panelists were Matthias from Uhurutech, Maria from Cloud and Heat Technologies, so two Alaska members, which is great, and Jan Klare from OSISM. And it was really a great panel, just overall. Yeah, talking about all of the advantages why direct competitors do decide to then all work together in associations like Alaska and the Sovereign Cloud Stack in order to further advance standards for open source cloud infrastructure. So that was great. And then we also had a little lightning talk held by Matthias Büchse. He's the project manager at Alaska Focus. And he talked on, or he presented the OOC operator for SES compliance, and he just gave a quick status report and some next steps. Other than that, there is the EU Sovereign Tech Fund, which when we went to FOSS Backstage 2 months ago in March, we sat in on a presentation by the Open Forum Europe. And they presented the EU Sovereign Tech Fund, which basically is a tech fund for EU sovereign technologies. So it's similar to the Sovereign Tech Agency here in Germany. And from my understanding, what they want to address with this is the problem of funding always being given out to the development of new projects and new open source projects, but then when that development or the initial development is done or the funding runs out, then people are left with a project and no one to maintain it or no money to maintain it. And that, I think, is an issue that we are all aware of, the way that funding really works currently in that space. And so they are focusing on addressing that on an EU-wide scale. And since we think that that's a great idea, Alaska decided to endorse that initiative. You can also see here, those are the new endorsers. So there's two more Alaska members that also decided to endorse it, which is great news. And endorsing in that sense just means publicly saying we agree that this is an issue and we support that there should be something done about that. And right, so that would be that. Other than that, we have the hackathon coming up. It's on July 1st and 2nd in Stuttgart-Vaihingen, just like last year. And it's just 2 days of hacking and fun and great conversations and networking. And if you want to join, you are very, very welcome. I think there's still like 5 seats left. If you want to join, you can just register via the QR code or anywhere on our website. You can find the link to the registration. It's free of charge, of course. It's just so that we know who wants to eat and how many people are coming. And what we want to do there is just further develop our Alaska open source project. So there will be a group for Seconle, which is one of our newer projects. And then there will also be a group for Taruk and another group for Yauk. And then there will be members of this TSC, the Alaska Technical Steering Committee, who will be leading a group for NAI policy. So there's just different aspects within the association that we want to work on and that we want to further advance. So if you want to join us, you are very, very welcome to do so. Alaska Summit, we talk about it every month. However, it was brought to us that it was not abundantly clear that the registration and the call for contribution is currently open or has been open. So I want to emphasize this again. You can register for the summit, please do so. And you can also turn in your contributions for your talks and workshops. What we're looking for are lightning talks, 10 minutes, presentations, 20 minutes, and the long workshops where you actually have enough time to really look at things and really dive in deep and get some hands-on experience. And yeah, we would really like to curate a widely varied program for our community and for you guys again this year. So we really would love it if you could contribute so that we are able to do that. And so if you have a new project, a use case, some lessons learned, these are always very welcome. So feel free to turn yours in. The call for contribution is open until July 31st. And other than that, as I said, the registration is open. If you want to join, you already know you're coming. Feel free to register. And other than that, we are hosting our event at a hotel this year. And we have blocked all those rooms to make it extra comfy for you guys. So if you are coming from out of town and you know that you are going to stay in a hotel, which you will if you come from out of town, then you are very welcome to use one of those rooms. All you have to do is to write a quick email to the hotel with the keyword of Alaska and then just say how many rooms you would like to block. You can't find the rooms online for those dates because we have blocked them for Alaska so that they can't be taken by other people. So as I said, if you want to book that hotel and you just want to sleep at the event location, then you can. And if you have any questions on that, you can always text me or email me. All right, so that then would be that for this year, for this month's Tech Talk. And other than that, all that's left to do is announce the following Tech Talk for June, which will be on June 26th at 11 a.m., of course, and it'll be held by Cyberus Technologies with a title that is not yet here. So we all get to be a little bit more excited for a little bit longer, and I'll be sharing that title once it's here. And if no one has any further questions, wishes, hopes, and dreams, then that would be it for this month's Tech Talk. Okay, I'm seeing a thumbs up. I was just wondering if I was still here, or if you guys weren't able to hear me anymore. But you are, so that's great news. And then with that, I'm going to let you all go to lunch. Thank you so much, Tassilo. This was great, and I'll see you next month. Bye.